Hello, welcome once again to our second episode. Today we'll be learning about soil physics part 1. I'm Sylvester Odundo, a trainer at Friends College Kaimosi. My email address is odundosylvester54@gmail.com and my phone number is 0706 248 870. So what is soil physics? So we are going to discuss soil physics, and we can refer to soil physics as a study of soil physical properties and processes. We can also say that it deals with the dynamics of physical soil components and their phases as solid, liquids, and gases. So in this episode, we are going to be talking about soil physical parameters. Two of them, one is soil texture and another one is soil structure. So let's go straight away. So we define soil texture as the relative proportion of various soil separates in a soil. It is usually expressed on percentage basis, and the soil separates are a group of soil particles of given size range, that is, different size of particles which together make up a given soil. Now when we're talking about soil texture, we're talking about the separates in terms of sand soil, clay soil, and silt. So when we are talking about soil separates, then what we mean, we are talking about particle in the soil in terms of sand, silt, and clay. So what are the characteristics of sand? One is that they are made up largely of sand particle size. They have large pore spaces because of the large diameter of the sand particle size, and because of that, they end up having poor water retention. They are easy to till because of the pore spaces in between the particles. They are freely draining because of large spaces of air. They are low fertility due to leaching of minerals. Now remember, the leaching process is actually the process where nutrients are sipped under into the lower horizons, and because of the spaces in between, which are large, water carries along the nutrients into lower horizons. Then we can also say they are easily erodible, and when we're talking about loam, which is an intermediate particle size in between sand and clay, we are talking about them having equal amounts of sand and clay, and they are moderately good in both moisture and air retention. And lastly, we can also refer them as very fertile soils compared to sand or clay. On clayey side, they are made up largely of clayey particles, have very small pore spaces, and therefore they are good in moisture retention, and that's why you find this kind of soils in water ponds. They are difficult to till, they are heavy soils, and also poorly draining. They expand when wet and crack when dry, and they have high capillarity. And lastly, we can say they are rich in plant nutrients because they have the colloidal properties, the electronegativity properties that enable them to attract cations. And some of these cations, such as magnesium and potassium, they end up being attracted and they become part of the nutrients, that is nutrient capital for the plant to use. Next, we want to talk about the soil classification, and classification of this particle size may either be under ISSS, that is International Soil Science Society classification, which categorizes the particle size in terms of fine sand, silt, and clay, where clay is anything less than 0.002 and fine sand anything more than in between 0.2 to 0.02. Then we have classification under United States of Development Authority that gives their classification in this order, that anything above 2, that is regarded, between 2 to 1 is regarded as very coarse sand, and anything less than 0.002 is regarded as clay. So in determining the soil texture using the hydrometer method, the equipments and reagents that you need. So one is analytical balance, This helps you weigh the amount of sand that you need. Standard hydrometer gives you the density of a particular solution or suspension. Reciprocating mechanical shaker helps you do thorough mixing of the suspension. We have also the cylinder that is marked to 1 liter, which is very important. It gives you the volume of the suspension. And lastly, in this column, we have the shaker bottle that has a cap. I prefer using conical flask because you can be able to shake very well without it spilling out. We also need reagents. Some of the reagents that are needed are: one, deionized water. Make sure that water is deionized, it has no ions, so that it doesn't cause any reaction when it mixes with soil. Remember, soil has minerals and it may end up causing some reactions to occur. Amine alcohol is very important so that you may be able to eliminate any frothing that may occur in the process of shaking your suspension. Lastly, which is very, very important, is sodium hexametaphosphate solution. We also refer this as calgon. This helps in dispersion, and when it is applied, when it is added into the suspension, it causes the soil particle size to disperse so that you can be able to separate the clay from the loam and from the sand. Yes, so when we're talking about the procedure of carrying out the hydrometer method to determine the particle size, first you need to weigh 40 grams of air-dried soil pulverized to pass 10 mesh sieve into 200 ml container. In this case, I prefer using conical flask. 2, you need to add 100 ml of calgon or sodium hexametaphosphate solution. Remember, this solution helps in dispersing the soil particles because it has sodium that causes the dispersion. So you need to cap and place on reciprocating horizontal shaker for 16 good hours. Next, you need to quantitatively transfer the suspension to the sedimentation cylinder and add the ionized water to bring it to 1 liter final volume. Next, you allow the suspension to equilibrate to room temperature for 2 hours. Insert plunger and thoroughly mix contents, dislodging any segment from the bottom of the cylinder. You need to add 2 ml of amine alcohol to the surface to suspension covered in foam. You need to repeat the process and determine hydrometer reading on a blank solution. Now, it is very important for you to get a reading of the hydrometer reading for the blank so that you can be able to minus to actually remove any errors that may come along with the water. Then lower the hydrometer carefully to the suspension after 30 seconds and take the reading after 40 seconds in order for you to read the sand density. So next, you remove the hydrometer carefully, rinse and wipe dry, and later you reinsert the hydrometer carefully and take a reading record as R clay. That is after 2 hours. So when you be doing the calculation, you need to remember that first, you need to minus the reading that you have gotten of sand from the blank. That gives you the hydrometer reading of actual sand. Now, remember, our volume is 1 liter and our density is the reading that you have gotten of our sand. So that means, therefore, our mass, if you calculate using density is equal to mass over volume formula, then you find the reading of the hydrometer is exactly equal to the mass of a particular soil. So in this case, we have R sand. So R sand gives the reading, the hydrometer reading of that is given after 40 seconds, give you the mass of our sand. Next, you have your clay. After 2 hours, the reading gives you the mass of clay. If you want to get the percentage, then is equal to 100 minus the summation of clay and sand. So if you want to know the textural class in which the particular soil falls into, then we have a triangle that we refer as textural class triangle. Now, this triangle is very, very important. Remember, it has clay on one side, percent silt on the other side, and percent sand. Following those arrows from the origin, depending on the particular percent that you have gotten, then it is easier for you to know, like let's assume that you have sand which was 10, then that means that direction is going to go that direction. Let's assume we had silt which is 70, then that means that direction is going to connect at that point. Then if silt, let's assume that you had clay that was 22 or 23 there, then that means you are going to have that line go that direction, and your soil textural class is going to be silt loam. Next, we want to talk about soil structure. This is another. Yes, so what is the importance of soil texture on crop production? So, number one, it influences soil fertility. Number two, it affects organic matter content. Remember that depending on the amount of clay inside that particular soil, you may find a soil that has high clay, then that means it has high colloidal properties. Then that means the cations are going to be attached to the clay particles, and therefore improves the soil fertility. The same to organic matter. Next, it influences the drainage of the soil. Depending on the given percent of a particular separate, if sand is too much, then you expect the drainage is going to be high compared to when a soil has little of that sand. It influences soil erosion because of the pore spaces, depending on the particular separates that is in high amounts. It also influences water holding capacity. And lastly, we can say that it influences the capillarity or movement of water in the soil. So we want to also talk about structure. So we want to talk about soil structure. This is a very important parameter in soil physics, and it refers to the aggregation of primary soil particles, that is sand, silt, clay, into compound particles. Now, when we are talking about structure, we are just talking about how different building blocks can be able to come up with something that you can be able to see. Structure modifies the effect of texture in regard to 1. Moisture and air relationship. 2. Availability of nutrients. 3. Action of microorganisms. And lastly, the root growth. So, like for instance, in a highly plastic clay, or let's say 60% clay, it is good for crop production if it has a well-developed granular structure, which may end up facilitating aeration and water movement. Now, we also want this soil structure can be classified in different ways in terms of grade, class, type of aggregates. Now, so the next slide, we want to talk about the classification of soil structure. It can be by grade, it can be by size, or it can also be by shape. And we want to talk about all of those. So we start by grade, is the degree of aggregation and expresses the differential between cohesion within aggregates and adhesion between aggregates. We can also say these properties vary with the moisture content of the soil, and it should be determined when the moisture content is normal, not when unusually dry or unusually wet. Now, when we're talking about grade, what we mean is we may have 0, 1, 2, 3. For 0 is referred as structureless grade, and this we can be able to say that there is no observable aggregation or no definite orderly arrangement of natural lines of weakness. And weak, these are those kind of structured soils that degree of aggregation is characterized by poorly formed indistinct aggregates that are barely observable in place. Grade 2, which is moderate, is well-formed distinct aggregates that are moderately durable and evident but do not distinct in undisturbed soil. And lastly, we have free, strong. They are durable aggregates that are quite evident in undisturbed soil that are there quickly to one another. Now, classification of soil structure by shape. We have simple. Now, under simple, we have single grain and massive structure. Then the next, we have compound. Under compound, we have spheroidal. Example is granulate ground, block-like, blocky, subangular, blocky. prism-like, example prismatic, columnar, platey-like, flat, plat-like. These are soils found in compacted soils. Remember, when we are talking about compacted soil, we are talking about soils that you may end up finding hard pans upon in them. Then we also want to talk about the classification on basis of shape of pores and size. So we have coarse pore. Those are those structured soils with more than 200 micrometer pore size. Medium pore, we have between 200 and 20 micrometer pore size. Fine pore, we have 20 to 2 micrometer pore size. And lastly, we have very fine pores less than 2 micrometer. Now, types of soil structure, we have diagrams that explain that in the next slide. But this one, we have single grain, we have crumbly, we have granular, we have prismatic, we have columnar, platey, and blocky. Remember, when we're talking about crumbly, we are giving example of a structure such as that of bread. Granular, these are just granules. You can be able to pick them out, and they can be able to combine together. Columnar, they're just like columns, from the word columns. Blocky, from the word blocky. Platey, from the word platey. And this resembles plates, and they're majorly found on the subsoils where you may end up having hard ones. So these are, we also have structureless. Now this is the one that cannot be able to hold together. Then the next slide, we're talking about the pictorial presentation of the same. So you've columnar, so that is columnar. We have prismatic, we have crumbly structure, we have plotty, single grain, blocky, and granular structure. Another pictorial diagram, we have this also that explain better, and we're saying that granular resembles cookie crumbs and usually less than 0.05 centimeter in diameter. Blocky, the irregular blocks that are usually 1.5 to 5 centimeter in diameter. Prismatic, they are vertical columns of soil that might be a number of roughly 1.5 centimeter long, usually found in lower horizons. Then we have columnar on the other side, we have platey, and single grain soil that you can be able to pick out as grains. Then what are the importance of soil structure and production? So soil structure, number one, soil aeration is very important. Remember, whenever there is germination, there is life. So that means the life of a particular plant or the root will depend on the air that gets into the soil. So it is very important, and also it affects germination and root growth plus development. If the soil is heavy structured, if it is poorly structured, then that means the root may not be able to penetrate very well. Then soil drainage and water holding capacity is also influenced by the soil structure. Now remember, soil drainage is a factor of soil texture. So if soil drainage is affected, then that means water holding capacity of that particular soil is also going to be affected. So poorly structured soils have poor soil drainage, and well structured soils have high drainage capacity. The water drains very well, and the water holding capacity is also very good. Plant root penetratability and anchorage is also enhanced when the soil structure is good. Microbial activities, given the fact that microbes depend on oxygen for survival, and soil aeration is influenced by soil structure, then it is obvious that microbial activities will also be influenced when the structure is interfered with. If it is heavy or if it is very poorly structured, then microbial activities are going to be inhibited, and the opposite is true. The circulation of gases. Remember, soil acts like a sink of oxygen and other gases, so the circulation of gases would be affected if the structure is very poor, and if it is very good, then the circulation is enhanced. It also affects nutrient holding capacity of the soil. Now, when we're talking about the nutrient holding capacity, we're talking about the ability of the soil to hold onto the cations and other base the ability of a soil to be highly base saturated, and because of that, substructure plays a very important role when it comes to the capability of that soil to hold nutrients. Lastly, it also influences the soil thermal properties. When we're talking about soil thermal properties, we are talking about soil temperature. There are soils that may be poorly in terms of the temperature, and therefore the germination might take long compared to other soils which are well structured, which at the end of the day improves the soil thermal properties, and the soil temperature may be improved, and therefore germination is also enhanced. Yes, now the farming practices which may improve the soil structure, one is the application of organic manure into the soil. Very important to note that organic manure, in the process of decaying, they actually release some kind of a chemical that brings about cementation of soil aggregates together, soil granules together, so that at the end of the day the soil structure is improved. Tilling of the land at the right moisture content is very important. If a soil is tilled when it has a lot of water, then it means that after the water, when the water evaporates, then that soil becomes so solid, and you cannot it and may also create a hard pan, and therefore the structure may be poor. So you need to consider you're tilling the land at the right moisture content in order for you to improve the soil structure. Now, when we're talking about crop rotation, we are talking about changing of cropping season with different crops. Like if this year you've planted beans, next year you plant maize, the other year you plant vegetables, or in the same piece of land. When you do rotation, then what it means is that the rooting system of these different crops that you've rotated may end up creating a root zone that will collect, especially for those roots that are fibrous, they may be able to collect the granules of soil together so that the soil structure is improved. Minimum tillage is a practice that is encouraged so that you may be able to improve the structure of the soil, because in this kind of practice you don't disturb the soil at all. You try as much as you can to minimize any plowing, total complete plowing of the land. Then we also talk about cover crop. When we're talking about cover crop, these are just crops that can be able to cover when in their right stage, so that the foliage covers completely the land surface. So by so doing, the structure of the soil is also improved. Remember, the vegetation from these crops will shed onto the soil, and in the process of shedding they decay, and in the process of decaying they release chemicals that will end up cementing these soil granules together. We have mulching, which is also very important. Now what mulching does is that it retains moisture under the soil, so that that moisture can be able to hold together or to cause it can be a media through which the granules can be able to attach to each other. Thank you so very much. I hope that you'll be looking forward to the next episode, which is going to be soil physics part 2. And please subscribe so that you'll be the first person to get information on this channel. Thank you, and bye for now.